to talk about some symbolism on here. When you see these two triangles pointing in the same direction on two lines, this means that these lines are parallel. Okay? Yeah, these two triangles on the lines that go in the same direction, whenever you see two triangles going in the same direction on two lines, that means that those lines are parallel to each other. Okay. Then we have what's called the corresponding angles postulate. And if you do or don't remember, we defined a postulate as a statement accepted as true. We don't have to prove these. They're just, we accept that they're true. And the postulate is that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Okay. So if we call this line A, B, and C, okay. So what we'd have is B is parallel to C, A is a transversal. Okay. One and 5 are corresponding because they're in the same position. If you made this like a checkerboard, they're in the same top right corner, top left corner, sorry. I know my right and left. And then 2 and 6 are in the same top right corner, 3 and 7, bottom left, 4 and 8, bottom right. So what we're going to get is that angle 1 will be congruent to angle 5. Angle 2 will be congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. And this is based on position, not number. So if these were numbered differently, 1 is not always going to be congruent to 5. It's about where they are in position. The reason this works is because if you have two parallel lines, the lines have the same slope. And so the slopes are going to be the same, which means that the distance from here to here is going to be the same. That makes the angles the same. So that's how that works. Use this postulate if the measure of angle 5 is 72. So 5 is right here and it's 72 degrees. Okay. What I usually do is I go through and I use color to identify corresponding angles. And I do have markers on the shelf down there if you want to use them. I find personally color to be very helpful in this chapter, but that's me. So everyone that's the same color is the same degree. Okay. Well, 5 is 72. That makes 372. And I want to find angle 4. And angle 3 and 4 make a straight line. And we know straight lines equal 180. So to find angle 4, I'm going to do 180 minus 72, which is going to be 108. Okay. Now I want to find angle 2. Well, angle 2 is across from angle 3. Angle 2 and 3 are vertical angles. And vertical angles, so I'll just put vertical to angle 3. And I'll just say angle 3 equals angle 5. I shouldn't say equals, congruent, because they're corresponding. And then angle 3 and angle 4 will equal 180, because it's a straight line. And then angle 2 and 3 are vertical angles, and what do we know about vertical angles? They're the same. Vertical angles are congruent. So if angle 3 is 72, that means angle 2 is 72 degrees. Okay. If you did not remember the vertical angle thing, you could still find angle 2 because you now know angle 4 is 108. And angle 2 and angle 4 make a straight line. So you could subtract from 180 that way too. So there's two ways that you could find angle 2. Vertical angle is probably the simplest because you don't have to do any subtraction, but the straight line thing works too. Okay. Now, if angle 8 is 105, now obviously that doesn't work with the 72, but we're just going to hypothesize. So I'm just going to draw two new things, and I'm going to say this is 105. Angle 1, being in the same position, will be 105. Angle 3, so this would be 105 too. Sorry, that's way too small to read. I'm going to do 180 minus 105. So angle 3 in that case would be 75. And then angle 2 is the same as angle 3. So it would also be 75. Now, theorems have been proven or have to be proven. Okay, so we don't accept these as true, except that I'm going to tell you that they're true and they have been proven. Okay, we have the alternate interior angles theorem, and that says if two parallel lines are cut by a transversal, okay, then alternate interior angles are congruent. Now this only works with parallel lines. So the transversal lines we were doing on Thursday where the lines weren't parallel, this isn't true. It's only true if we have parallel lines. Okay. So what I'd have is this angle here is congruent to this angle here. Actually, you know what? I'm not drawing that down there yet. Let's draw this up here. We'll say these are parallel. And here's my transversal. So this angle is the same as this angle. And this angle is the same as this angle. Then I have a consecutive interior angles theorem that says if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. Okay, so from our picture, say same picture, green and red equal 180. So this green plus this red will equal 180, And this green plus this red will equal 180. But also these two would equal 180 because you see they make a straight line, and so would these. Okay. And then you have the alternate exterior angles theorem, which, again, if two parallel lines are cut by a transversal, so if I have these two parallel lines in this transversal, this angle is the same as this angle, and this angle is the same as that angle. What you get when you put it all together are four angles that are congruent to each other. Reds all equal each other, and greens all equal each other. So bless you. So any red angle equals any other red angle. Any green angle equals any other green angle. And any red angle plus any green angle will equal 180. So I could pick this angle here and that angle there. Those two are going to equal 180. What do you do with these? Yes. Reading Lane and Creek Road are parallel streets that intersect Park Road. Okay, so I'm going to draw my triangles so I can indicate that these are parallel. Okay. Along the west side of Wendell Park, if the measure of angle 1 is 118, find angle 2. Well, what do I know about these two angles to each other? Angle 1 and angle 2 are alternate interior, which means they are congruent. So angle 2 is also going to be 118 degrees. Okay. If we take the same diagram above and we say angle 1 is 100 degrees, we want to find angle 4. Well, if I do my checkerboard, like that, 1 is green, 4 is red. Didn't show very much, but 4 is red. So angle 4 is going to be 180 minus 100. Because one's green, one's red. If we do the same thing and angle 3 is 70, 3 is red, 4 is red. So that makes them the same, so 4 would be 70 in that case. So we should put like maybe an if here, because they're not obviously the same setup, but our key concept is that all of these angles are the same. All of these angles are the same. So we have all green are congruent, and all blue are congruent, and any green plus any blue will equal 180. And that's if A is parallel to B. They have to be parallel. And again, to tell if they are or not, they should either say parallel somewhere like A is parallel to B, or they'll have these triangles to indicate that they're parallel. Okay, any questions on these? Are you guys still working on them? No questions? Okay. Let's look at this next set here. Okay. Lines Y and Z are parallel. They're labeled with those triangles that I was telling you to look for, but W and X are not parallel. So Y is parallel to Z. W is not parallel to X. Okay? What that means is that these angles will have a relationship along X, and these angles will have a relationship along W, but we don't have a relationship going this way. Okay? So if I were going to mark these for congruency, those would all be congruent with each other. These would be congruent with each other, and then the ones without a dot on them would be congruent. I only have 3 colors with me, so I can't mark those. Okay. Now, if we had 2 sets of parallel lines, so just hypothetically, if these were parallel here, and these are parallel here, then you get a relationship among all of the sets. Okay? The difference being, in this case, both sets of lines are parallel. But in this case, only one set of lines is parallel. Does that make sense? So that's when you have parallel lines, only one set's parallel, you go along the transversal that's not parallel to determine the checkerboard pattern. If they're both parallel, you can just go through the whole thing, and you'll have a bunch of congruents. Okay, so looking at these, being told angle 3 is 75, and angle 10 is 105. Okay. Angle 2 and angle 3 are going to add up to 180. So this is actually going to be 105. Angle 7 is the same color as angle 2. Angle 14 and angle 10 are going to add up. So that will be 75 in this set. Angle 5 is purple. So it's the same as angle 2. Angle 15 is white, so it's the same as angle 10. And then angle 9 is pink, so it's the same as 14. Now what ended up happening on this particular example is we ended up finding angle measures that would mean that W and X were parallel. But we can't assume that. We have to go through and assume that they're not parallel and then do math. And once I did the math and I realized that every angle I'm getting is 75 and 105, that tells me they were in fact parallel, but because they weren't labeled, I had to assume they weren't. Okay. So far okay? Yes, good, bad, ugly, indifferent? Okay. All right, so let's look at what happens when we throw algebra into the mix. Okay. The first thing I always want to do on these, this is me personally, as I go through and I use color. And then I know all the green are equal and all the blue will add up to 180. Okay. Then I look at this and I say, okay, angle 4 is blue. Angle 1 is green. Blue plus green equals 180. Oh, yeah, sorry. Just, going about my own business. Sorry about that. Thank you. Better? Okay, so I went through and I labeled them all green and blue. And then I circled angle 4 in blue because it's blue. And I circled angle 1 in green because it's green. And then blue plus green equals 180. So that tells me this plus this equals 180. So I have 2x minus 17 plus 85 equals 180. Okay. If these were both blue or both green, I'd put an equal sign in front of them. But since I have a blue and a green, I do that. Okay, so I have 2x plus 85 minus 17, which I don't have that memorized. 68. Okay. I'm going to subtract 68 from both sides to get that 2x is equal to 112. Divide both sides by 2, and x is going to be 56. Okay. And that's all I had to find was x. I wasn't told to find the angle, I was just told to find x. Now that's not the only way you can do this. Okay, there's one other way to do this. I know that blue and green add up to 180, and I know that green is 85. So I could have said, okay, well that makes blue 95, and just set this one equal to 95. So there's two ways to go about this. I like to set it this way because then I always remember, because if this has x's in it as well, that makes it easier to work with. Okay, here I have 3. Angle 3 is green. And angle 7 is also green. And green angles are equal to each other. So I'm going to set these two things equal to each other. So 4y plus 30 is equal to 7y plus 6. I'm going to go ahead and subtract 4y from both sides. And then get 30 is equal to 3y plus 6. So 24 is equal to 3y. And then I divide by 3. And y will be 8. And again, I only had to find y. I didn't have to find any angle measures. So I can stop. For this problem, plus or equal? Plus. And it will equal 180. So I'm going to do 4x plus 7 plus 2x minus 3 to equal 180. Okay. The next thing, collect like terms on the same side. Probably shouldn't have used blue and green there, but it's too late now. Subtract 4. divide by 6, and I have no idea if this will work, but we're going to do it anyway. 6 goes into 17 twice with 5 left over, and then it does not go into 56. So I'm just going to reduce these by 2, and I'm going to get 88 thirds. Or you can do a decimal. Okay. For D, plus or equal? Plus. Because they're both, one's blue and one's green, so they're going to be plus. So 68 plus 3y minus 2 is equal to 180. So 3y plus 66. I'm going to subtract 66 from both sides. And 3y will be equal to, let's see, 180 minus 60 is 120 minus 6 is 114. Divide by 3, and y would be equal to 38. Okay, so I had, those are all equal, and these are all equal. Okay. So if we look at that, 5x and 40, one's blue and one's pink, so they'll add up to 180. Okay. So if I subtract 40 from both sides, I get 5x is equal to 140. Divide by 5, and x is going to be equal to 28. Okay. And again, that's because one was pink and one was blue. Now when I look at y is pink. And the thing that y matches is the 5x. But I also know that blue is 40, so I could say that plus 40 is equal to 180, like that, because blue plus pink equals 180. So 3y plus 39. If I subtract the 39 from both sides, I get 3y is equal to 141. And if I divide by 3, I get y is equal to 47. Questions on that one? At all? Nobody? Okay, so now we have a blue and a yellow. If I look at my x's, they're both yellow, right? So since they're yellow, that makes them equal to each other. So 11x minus 1 is equal to 9x plus 21. So 2x minus 1 is equal to 21. And then add 1 to both sides, and you get 2x is equal to 22. So x will be 11. Again, because they were yellow, so they're equal to each other. It'll be all on mine. Okay. Now, I have a blue for my y. I need to figure out, like, what this equals so I can have something to go off of. So I can either plug it into this, plug x into the 11x minus 1 or in the 9x plus 21. I'm just going to do 11x minus 1. So 11 times 11 minus 1. So that's 120. So if this is 120, what's this? 60. 60. Okay, so that would mean 5y minus 5 would be 60. Does that make sense? Okay. Add 5 to both sides. So 5y is equal to 65. Then divide by 5 and you're going to get 13. I don't have any other x's, but I have that this purple is equal to that purple. So 3x minus 3 is equal to 60. Okay. So you add 3 to both sides to get 3x is equal to 63. So x will be 21. Okay. Now with my y, I have a pink and a purple, so I can either say this plus this equals 180, or I could figure out what value this is. Which way would you like to go with that? All right, we'll just do the plus to keep everything the same. Plus 60 equals 180, so pink plus purple is 180. So that makes 64. So subtract the 64 from both sides, and you're going to get 116. And if you divide by 4, you'll get 29. Okay. So same color equal 2 different colors, add equals 180. Does that help? Plane, so we're in a flat surface. If a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Right? So if we come in here and we have two parallel lines, here and here, those are triangles. I know they don't look like it. And this line is perpendicular. This line is also perpendicular. What are all of these angles? All of them are 90. They're all perpendicular. That's why I said this is kind of one of those theorems where I'm like, yeah, duh. Because it makes sense, right? If you're 90 here, you're 90 here, you're 90 everywhere. So, but I have to give you the theorem. So I gave it to you. Now you guys know the perpendicular transversal theorem. Feel special? For homework, do page 34. Okay, and I will see you tomorrow.